So now we are doing circles. What is a circle? Circle is a plane closed curve. First of all, you must understand it is a plane closed curve. Plane means it is going to lie on a two-dimensional surface. It is closed means you will not see it opening from any point, right? It will always be having some closed path, and it is a curve because it is not straight. So it is a plane closed curve comprising of all those points whose distance from a fixed point remains constant. Now what do I mean by this? Say for example, this is a fixed point, right, A, and we have so many other points B, C, D, E, F and G. Now we have all these points. Can we find out the distance of all these points from the center? This one. This is the distance of each point from the center, and we say this distance is equal. That means all the distances of all the points of the respective points is same from this fixed point A. So that means if you see the line which is comprising all the points, all these on this place, yeah, you can see D, C, B, G, F, E. All the points are comprised of in a curve. That curve is known as your circle, right? And because this distance is going to remain constant for all the points, you can have so many other points also on the circle which are going to remain at the same distance from this fixed point A. That was about the circle. Now what is center? Center is a fixed point on the circle from which all the points on the circle are equidistant. So here the point that I took was A, right? So this point over here from which all the points on the circle are equidistant, that fixed point is known as the center. We can have centers for these circles also. This is the center, this is the center from which all the points on the circle are going to be equidistant. Next we have the radius. The fixed distance of any point P on the circle from the center. You can take point P anywhere on this circle, right? This can be P, or this can be P, this, or anywhere on the circle. Any point can be a P point which is at a fixed distance from the center. So this distance from the center is known as the radius of the circle. This fixed point is known as the center of the circle, right? These are the two very important parameters of a circle that you must know. Next we have the circular region. Now the circular region is divided into two parts, that is interior and exterior circular region. Interior means that will be having points at a distance from center which is lesser than the radius. Now that means over here I have marked the interior of the circle. This is the interior, and in the next figure I have marked, or you can say I have shaded, the exterior of the circle. The difference is that if this is interior of the circle, all the points that are going to lie here, say A, B, C, D, E, are at a distance from the center which is less than the radius, because the radius would be this value, and all these points from the center are at a distance lesser than radius. So if the points are at a distance less than radius, all of them are lying in the interior of the circle, correct? Now what about the exterior? If I want to discuss the exterior part would be here. So we can have the points outside the circle, right? Now you can check that distance of these points P, Q, R from the center, the distance of these points from the center is going to be greater than the radius, because this is the radius but these points are lying away. So you can check that the distance would be greater than the radius, right? So these points P, Q and R are lying in the exterior of the circle, and points A, B, C, D, E are lying in the interior of the circle. Now we have the chord. Chord is the line segment. Please pay attention. Chord is a line segment joining any 2 points on a circle. Now that means you can have a circle like this. This is one circle and these are any 2 points on the circle. If you want to join these 2 points with a line segment, this line segment AB is representing the chord. AB is the chord of the circle because it is a line segment that joins any 2 points on the circle. Your 2 points can be anywhere else also, right? One could be here, other could be here. Just 2 points on the circle are joined by a line segment. That line segment is known as chord. Here only we get another term, that is diameter. Diameter is actually the longest chord of the circle. What will be the diameter in this case? The diameter would be here, that is the longest chord possible. The 2 points on the circle are joined by a line segment which is passing through the center of the circle, right? So this is the possibly maximum, or you can say the longest chord of this circle. So that is known as the diameter. So we'll name it as diameter now. Next is the secant. In secant we have the line intersecting circle at 2 distinct points. Now there could be a line which intersects this circle at, say for example, this is one line. Now this line is intersecting the circle at 2 different points. You can see that on your own, here and here. So if there is a line, I am not saying the line segment, I am saying it is a line. Line is this, line segment means which has end points. So if a line segment is there which is passing through 2 points on a circle, that is a chord. If there is a line passing through the 2 points on a circle, that will be known as a secant. So we have this as the secant of this chord, you can say secant of this circle. So I have named it as secant. Next is the tangent. Tangent is also a line which meets a circle at 1 point only. So you can say the difference between secant and tangent is that secant meets the circle at 2 points, whereas the tangent meets the circle at 1 point only. So how do we make a tangent over here? We can make a tangent here going like this. This is the tangent passing through the circle. So this tangent is meeting the circle only at 1 point. So we can say this is the tangent. So I am going to write over here tangent so that you can understand where is the tangent shown, right? So that is the tangent, as it is a line that passes through the circle touching at only 1 point. Now we have the arcs. Pay attention, arc is nothing but part of the circle only between 2 points on a circle. Now the 2 points could be this, let us name it C. Now there are 2 points C and A. Now there is a part of circle which is shown like this, right? And there is another part of the circle which I am going to highlight with blue. You can check, this is another part of the circle. I am highlighting it so you can see how the 2 points are dividing the circle into 2 parts, right? One is the one that I have shown with the red boundary and the rest one is shown with this blue boundary over here. Now this blue boundary is showing you clearly that just these 2 points A and C are having 2 parts. One is this much and the rest is the blue, shown with the blue one. So that means the arc is always dividing the circle into 2 parts, and that is major arc and minor arc. So if you have the arc greater than the semicircle, now semicircle we were going to discuss later, but I will include it here only. In semicircle we have the half the length of the circle. So this is the half length of the circle, right? This is the half of the circle, that is the semicircle. So if you have the arc greater than the semicircle, that will be your major arc, and if it is lesser than the semicircle, it is going to be your minor arc. You can check over here, the red portion is lesser than the semicircular part, so that represents the minor arc, whereas the blue portion is definitely greater than the semicircular part, so that represents the major arc part. Okay, so now we have the circumference. As I discussed it in between only, circumference is actually the total length. That means if you start walking from this point and you followed a circular path, you came back to the same point. The entire length or the entire distance that you traveled is your circumference, right? So circumference is the entire length, but if you divide it into two halves, that is, you can do the half of the semicircle, that gives you the semicircle. Here you can write clearly that it is going to be the half of circumference, because as I discussed with you, semicircle is going to be the half of circumference. If you divide the length into two parts, the half of circumference is going to give you the semicircle. Next we have the sectors. Now for sectors we will be dealing with the regions, right? Until now we were not bothered about the regions, we were only discussing the points, the lines. But now we are talking about the region which will be enclosed by an arc. Now the region is going to be formed with the help of an arc and two radii, right, through ends of an arc. The two radii to be made are going to be done with the same arc. You can check over here, if this is the center, I take 2 points, that is, this is center O, I have taken A and B, 2 points on the circle, right? There is another arc between the 2 points. The arc between these 2 points is this, the one that I am highlighting with red, right? So this is the arc between the 2 points, and the other two things will be the two radiuses through the end of these 2 points. So the radius through the end is going to be like this for both the cases, right? Now the region between the two radiuses and this arc is representing your sector, or you can highlight it like this. This region, the ones that I am shading, is representing your sector. So we can write on this sector, and there are two types of sectors possible. One is major and other is minor. If the region is containing major arc, the sector will be major sector. For example, here only this arc is these 2 points are having another arc behind, that is the black one. So that is the major arc, and this red one is the minor arc. So if the major arc is there and you have the two radiuses to the ends of the arc, that is representing the major sector. So we can write over there that this, the unshaded portion, is your major sector, whereas in the lower portion, with the one that has been shaded, it has the arc and the two radiuses, so it represents the minor sector because it consists of the minor arc. Here you have the minor arc, and above where you have the major segment, major sector, you have the major arc, right? So it depends if you have the minor arc or major arc. If you have the major arc and two radii, it will give you major sector. If you have the minor arc and you have the two radii, that would give you minor sector.